David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Today's topic, exponential equations. But before we launch into that, I want to remind you that you're going to need your rules of exponents, or the laws of exponents. We're going to be manipulating exponents, and there's several things in there that are assumed prior knowledge. Now, I've provided you a link with a review video that goes over all those rules. So if you're not feeling up on it, or it's been a long time since you've played with exponents, you probably want to watch that video first and come back to this one. So remember, we're in an exponential functions chapter, and this is where variables show up in the exponents. So what we're going to do now is we're going to solve equations with variables and the exponents. Starts off pretty straightforward, gets tricky later. So we're going to do some of those tricky problems at the end of this video. So first off, let's just take a look at this pretty straightforward equation. I have 2 to the x equals 8. So it's kind of hard to see what x might be. So the overall process here is we want to rewrite these equations with the same base. So that's what I wrote here. Write both sides with same base. This is called equating the bases. Make the bases equal. Okay? So 8 can be written as 2 to the third because 2 times 2 times 2 is 8. So 2 to the x is the same as 2 to the third. So now it's pretty easy to see that if my bases are the same and they're equal, then x over here has to be 3. So these two numbers are the same. So x is 3. So pretty straightforward. You're going to get some problems like that. We can develop a basic rule. If a to the x equals a to the k, the bases are the same, then these exponents have to be the same. So then x would be equal to k. Okay? So let's do some more complicated examples. Okay, if you feel ready, pause the video right now and see if you can do these 3 problems. Okay, let's see how you did. 2 to the x equals 32. So what I want to do is I want to write 32 as some number with a base that's 2. So if we think about it, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 more is 32. So 32 is 2 to the 5th power. So I could write this as 2 to the x equals 2 to the 5th, and that gives me x equals 5. Okay? So I equated my bases, and then I can just make these two things equal, got x equals 5. Let's try that one. 4 to the x equals 64. So I need to be able to write 64 as some base to as not some base, as 4 to some power. And that's pretty straightforward because 4 times 4 is 16, times 4 again is 64. So 4 to the x equals 4 to the 3rd power. 4 to the 3rd power is 64. So now I get x equals 3. Done with that one. Try that one. Okay, what we need to do is we need to write 81 as 3 to some power. So let's check this out. 3 times 3 is 9. Times 3 again is 27. Times 3 one more time is 81. So 3 to the x equals 3 to the 4, because 3 to the 4 is 81. So now I can just go to x equals 4, and we're done. Okay, now we're going to do some more complicated problems. So buckle your seatbelts and follow along. 3 to the x minus 2 equals 1 over 9. That does not look like I can equate these bases, but if you stay with it, you can. Here's a nice simple base. Can't do too much with that. But 9 can be written differently. So I'm just going to carry this down. Equals 1 over 3 to the 2. Because 9 is 3 squared. That's good. Okay. Now I can come down here and go 3 to the x minus 1. Now 1 over 3 to the 2 is the same as 3 to the minus 2. Okay. So I'm going to pause for just a second. You've got to know your rules of exponents. I have a review video that talks about all those exponent rules. I'll share a link with you, and you can go watch that if you need to brush up. Okay, I equated my bases, so I get rid of them. X minus 2 equals negative 2. So add 2 to both sides. X equals 0. So there's my solution. Let's try that one. 2 to the x minus 1 equals 32. Now we know from before that we can write this as 2 to the 5th. So this is 2 to the x minus 1 equals 2 to the 5th. Because 2 times itself 5 times gets us back to 32. I get rid of my bases now that they've been equated. X minus 1 equals 5. Add 1 to both sides, x equals 6. So definitely a little more complicated, but perhaps not too bad. Okay, let's do a couple more. Here's one. 6 times 3 to the x equals 54. Now, our exponent has a nice base, but we're multiplying the whole thing by a number. So we want to simplify this side before we equate our bases. So what I'm going to do here is I'm just going to divide out the 6. Divide both sides by 6. These cancel. I have 3 to the x equals 54 divided by 6 is 9. That's a nice convenient number for this equation because 3 to the x equals 3 to the 2 because that's 9 is just 3 squared. So that comes down to x equals 2 and we're there. So if you feel ready, pause the video and try that one. Same process as this one, just a little different numbers. Okay, let's see how you did. Again, I've got a 6 multiplying my exponent. I have to use order of operations. I can't do my exponents yet. I have to divide away. 6 divide by 6. 2 to the x plus 2. That's canceling out those. 24 divided by 6 is 4. Now you're noticing that's nice because we can write 4 as 2 to a power. That's 2 to the x plus 2 equals 2 to the 2. These bases are equal. I can get rid of them. X plus 2 equals 2. Subtract 2 from each side, and I get another one with x equals 0. Okay, two final problems. You're looking at these going, oh my God, it's getting complicated. And you're right, it is getting complicated, but we're just going to tease it out step by step, slowly but surely, and we'll get to our solutions, I promise. Okay, let's take a look at this one. We want to equate our bases. So let's simplify those bases as much as we can. I am noticing a 4 here and a 2 there. That's giving me a clue as to what direction I'm going to go. So 4 can be written as 2 to the second power. So I'm going to do that like so. That's 2 to the second power. Now remember, this 4 is being raised to this power, so it comes out here. So I have 2 to the 2 to the x minus 1. And we're going to simplify that in a minute. Now, 1/2, interesting. This can be written as 2 to the minus 1, because this is 1 over 2 to the positive 1. And remember, for your exponent rules, you can move things up or down by making them negative or positive. So this is 2 to the 1, getting it up above, so it's just, instead of 1 over 2, it's 2 over 1 to the negative 1. And now this is 1 minus 3x. Okay, so now it's starting to look like I'm getting somewhere. I have two bases that are the same. I still have to deal with these powers here to get it simplified enough to get rid of my bases. So if you remember, for your exponent rules, if you're raising a power to another power, you multiply the powers. So this becomes 2 to the 2x minus 2. That's just 2 times x minus 1. Now this becomes 2 to the negative 1, because that's negative 1 times 1, plus 3x, because that's negative 1 times negative 3x. That goes positive. So now I have two bases that are equal. So I can drop them away and get 2x minus 2 equals negative 1 plus 3x. Now I have a straightforward linear equation which I can solve for x. So I'm going to subtract 2 from each side, minus 2x, and I'm going to add 1 to each side. So this side, these go away. I'm going to add 1 to negative 2, so that's negative 1. Now these cancel out, and I'm going to subtract 2x from 3x, leaving me with x. So I'm there. X equals negative 1. Okay? Now if you feel bold, see if you can give that one a try. Okay, let's see how you did. I need to equate my bases. Now, I'm noticing that there's a relationship between 9 and 27. They both can be written as powers of 3. 27 is 3 to the third power. Bring my x plus 1 over, because 3 times 3 times 3 is 27, and 9 is 3 to the second power. Bring over my x plus 3. So now, if you are following this problem, you have everything you need to know to simplify this further, equate your bases, solve for x. So let's try that. 3 to the third raised to the x plus 1, I multiply my powers. So I'm going to get 3 to the 3x plus 3. I'm going to do the same thing here. I'm going to get 3 to the 2x plus 6. Because I'm multiplying my 2 by my x and then 2 by the plus 6, so 2x plus 6. Now I have bases that are equal, so I can get rid of them. 3x plus 3 equals 2x plus 6. So now I have a linear equation that I can solve for x. I'm going to subtract 2x from each side, and I'm going to subtract 3 from each side. So these cancel, and these cancel. I have 3x minus 2x, that just gives me an x. 6 minus 3 is 3, and I'm done.